Okay, welcome to the first video tutorial on projectile motion. Have not yet figured out how to have a live video camera of me talking to you, so you just have to put up with a still shot instead. So we have a problem. An object is projected at 2 meters per second at an angle of 60 degrees. What is its maximum height? So these maximum height problems are a vertical motion problem. So all quantities like initial velocity and final velocity all have to be given as a vertical component. So let's start by working out the vertical initial velocity. So we've got 2 meters per second, sine of 60 degrees. And I know the sine of 60 degrees is root 3 on 2. I know that because I'm a very good student at math methods and I've learned all my exact values for sine, cos and tan. And that gives me root 3, which is approximately 1.7 meters per second. Okay, everyone agree? Yes, Mr. Stevens. Okay, so we've got our initial velocity in the vertical direction, and this is telling us that the object is traveling vertically upwards at some initial velocity. And it's going to keep traveling vertically upwards. However, the object is also experiencing an acceleration due to gravity downwards. So the acceleration due to gravity we're going to use is a negative 9.8 meters per second squared. Alright, and that's important. This is why we have a 9.8 in our time quantity. What is this time? This time here is the time it takes for the object to travel half of its journey from here to this point. Okay, and of course it travels that along its path up to some vertical maximum height. So let's get that value for time. I've got my initial velocity. Now, the question is, what value am I going to use? Am I going to use my exact value, or am I going to use my approximate value? And any time we use approximate values of a previous question in another formula, it's likely we could create more mistakes. So let's draw on our exact value, root 3. Root 3 over 9.8. Okay, from there, we're going to have to bring up our calculator. And we'll find that gives around about 0.17 seconds. Very short amount of time. Why is it so short? Such a fraction of a second. Well, consider how fast it's going. 2 meters every second. So you could say, well, maybe that's the speed of an ant kicking up a bit of dirt. Why not? From here, once we've got our time, then we need to do our last step, our vertical displacement. This is our maximum height. So let's work that out. I know my initial velocity is root 3. And now the time I've worked out is 0.17 seconds. And again, are we going to use a decimal approximation or the exact value? Always use the exact values that we've worked out, because that's going to help us eliminate potential errors. Okay, that's the first term. Second term, half 80 squared. Now this acceleration needs to be negative 9.8 meters per second. That's our acceleration due to gravity. So we put that in half, subtract half of 9.8 meters per second, and now our time value squared. Root 3 over 9.8 squared. Okay, so from there, by simplifying, we're going to get 3 of 9.8, but then times 2 in the denominator. So 3 over 19.6 as an exact value. Okay, and that can be worked out as a decimal approximation. And I don't have my calculator with me, so who can work that out for me? And our units are going to be in meters. So that's maximum height. Okay. So, next problem. What about if we're not after maximum height anymore, but we need to think about slightly different problem? Oh, too far. Let's go back a bit. So let's hide that one, and let's grab that one. This time, range. Now, range is vertical range. Sorry, not vertical range, this is horizontal range. This is the journey traveling from traveling from here all the way across. Now, in doing so, we need to draw in a few things. We need to know what is our initial horizontal velocity, because that's how fast it's going to travel horizontally from the zero. Initial velocity in the horizontal direction. Okay, so let's work that out first. 2 meters per second cos of 60. Cos of 60 is a half, so 2 lots of a half is 1 meter per second. Nice number. Okay, so that's a nice convenient number to help us with the other parts of our problem. Total travel time is the time it takes from the start to the end of its journey, and that's always twice the time it takes from the start up to the maximum height. So what we worked out before, our maximum height was reached in a time given by this term. Okay, so 2 lots of that now gives the full travel time. From the previous problem, the initial vertical velocity was root 3 over 9.8. So we're going to get approximately 0.34 seconds. Okay, now once we've got our time and we know the horizontal initial velocity, we're going to put them together in this rule here to get the range, the total horizontal displacement. So initial velocity is 1 meter per second multiplied by this time quantity, and again use exact values in your final calculation, and we get a distance of about 1 meter per second for that amount of time. It's about 0.34 meters, or 34 centimeters approximately. Like I said, ant kicking a bit of dirt. Okay. So from that, we can consider what happens next. And in my next video, we're going to look at an exam problem that takes the situation in reverse.